All right, welcome everyone. Thank you for making it till the end. I'm Marco.
And I'm István.
And we are both working for Tier. And today we want to share the journey that we took in order to start using Jetpack Compose in our hub. And we're going to share all the stuff that we had to do in order to be able to use Compose. Because guess what, and spoiler alert, in a bigger project, usually it's not that easy, and you cannot just import a dependency and start writing composable all around. But you need some work to do. And for us, we started mostly a year and a half ago, something like that, with the first experimentation. And now, after a year and a half, we have a lot of Compose. And we are pretty happy with that. We started slow, and then a lot of the people in the team started using it. And now all the new features are built with Compose, and we couldn't be more happy about it. But the thing that you may be wondering at the beginning is why? Why should you start using Compose if you have already an application that perfectly works, with views? Why should I migrate or even switch the technology and start using something else? Well, there are many reasons. But let's just be honest with each other. The main reason is that we are sick of writing those things. We cannot deal with that anymore. It's too much boilerplate. We don't want that. Of course, I'm joking, but I'm not joking. Because with Compose, there's less code to write. Things are more concise. And with a less amount of code, we can achieve the same thing or even more. And because of that, it's more fun to write things, even complex animation, complex stuff. It's funnier to write because everything is in Kotlin, and you can just write Kotlin code, no more XML styles and all those ugly things that we had to write back then. So because of those reasons, we were super happy about our experimentation. In our pet project, personal project, we were using Compose, but yeah, we didn't want to just use Compose only on the weekends, after work hour, but we wanted also to do it at work because, yeah, we are spending 8 hours working, something like that, so we want to be happy while doing that. But after the initial excitement, we quickly realized that we were not ready for that because there were a lot of things that didn't make us possible to start using Compose in a simple way. And yeah, let's start to check why we weren't ready. And by that, for that, let's start looking at the architecture that we had before Compose, and that we also have now in some of the scheme, but that's another story. And yeah, let's start by checking the view model, because the view model is the part of the UI, part of the logic that usually is close to the UI, so it's the thing that has to be in good shape in order to communicate perfectly with the UI. So in our case, we had, unfortunately, those beautiful, not beautiful things called bindable properties that, because, yeah, unfortunately, the project started with data binding, and I had to learn data binding. I was living a happy life, then I joined Tier, and I had to learn data binding, but never mind. So we had bindable properties, and so the state of the UI was split into different bindable properties. Also, we had custom binding adapters, because why not? Why having things simple when we can complicate stuff in the XML? And yeah, so because of that, there was a lot of logic was in the XML, and which is bad because it's very hard to test. It's not so beautiful. And on top of that, there was random tooling issue because sometimes data binding was not working for reasons. And those reasons mostly were KPT because, yeah, it wasn't. Sometimes there was just random things happening. And also, KPT now, as you may know, is a thing in the past because now there's KSP, which is much better, and you should not keep using KPT, but just move into KSP. Also because data binding is a thing of the past as well, is in maintenance mode, and you shouldn't using it, and you should migrate away for that, because also using data binding is bad for your health. So don't do that, please. All right, back on the view model, we also had a bunch of those things that are Rx relays, because yes, also on top of data binding, there was also Rx. And basically, we were using that for handling events, like events that comes to the view model with input, so for example, from an intent or stuff like that. And also we were using for output, so for triggering events, like for showing a snack bar or navigating, stuff like that. And also for some state, because why having a state in a single place when you can have it in two? So basically, we were sending some state outside with those relays, together with bindable properties, because in this case, sometimes you just wanted to react to something, maybe trigger an animation, stuff like that, or do more complex things that are not possible in a XML. And to complete the package, we also had Rx stuff all over the place in the view model, so just make a switch to another tooling, coroutines, for example, it will be more difficult. And yeah, we started already moving to coroutines, but yeah, it's more difficult with that state. But that's a topic for another talk. And so, given all of those things, just switching to compose was basically impossible because, yeah, good luck connecting a bindable properties to compose. And yeah, so it wasn't possible to just start and just write a composable and use the existing view model. So we had to fix some issue beforehand. So yeah, in order to untangle the stuff and switch out all the spaghetti that we had, I pass the ball to István.
Thank you very much, Marco. Do you hear me? OK. So as you could see in the previous few minutes, what Marco just painted, this picture wasn't so pretty. And we had to deal with that eventually, and we thought that it's time. So preparing for Compose is the time to get all these things better. What we wanted to do is just leave all those things behind, because that seemed like a good idea, start with a clean slate, and eventually do new features in a new way that would also incorporate supporting Compose on the long run. So yeah, also, we wanted to make this transition as easy as possible for our developers, so we started looking into documentation and new best practices that we haven't adopted for a long time. For that, we started looking into modern Android development, as we all should, and we started gathering ideas and methods that we could incorporate in our process. So let's get back to our beautiful and fortunately old view model setup. As you could see, the state was all over the place inside binding properties, which were observables and so on and so forth, data binding. And we also had this concept of an input and output interface. We are seeing now the output highlighted. And there we could have one or more or a lot of relays that relayed the parts of the state into multiple places of the UI. So that wasn't a good place to be. And also, with this output concept, we just crammed the events that are coming from the view model towards the UI into the same place, the same concept. So that also kind of mingled, but loosely mingled, with the UI state. So there, we now had enough things to complain about and enough things that we wanted to change. So yeah, we looked into how we could change the UI state as well, how we could handle it. Of course, there's official documentation for that as well. Thank you, Google. So we could also get some hints from there. And yeah, we started doing new stuff. We came up with this new base class that we call base tier view model. And it has one generic parameter, which is the type of the state that it will be outputting towards the UI. We also added an initial state, so when the UI actually gets hold of this view model, a state would already be present that the UI can render. And then, how to hold the state? Well, as of the recommendations, we made the view model the only state holder, of course, and we wanted to handle the state in one place. So yeah, we created a state holder inside the base view model class, which is, yeah, unfortunately, we had kind of deep knowledge on Rx and not so deep knowledge on coroutines and flows. So for this time, we stuck with a behavior subject. It does its thing quite well, so for now, it's OK. And of course, we had to hide the actual implementation, but we're still stuck with Rx, so we exposed the state stream as a state function which returns an observable to hide the implementation. So with this approach, of course, we reached a quite comfortable place where we could represent our UI state with one data class or a CL class hierarchy, of course, if the state was complex enough. And as you can see, the state is neatly in one place. Everything's there that the UI will need, and our developers will be happy because they didn't have to hunt for the parts of the state anymore. And of course, yeah, these are the parts of the UI, and we could also cram the events inside this state class, which is another recommendation that we read from Google. So for now, we went with this approach. So after this, we had our state handling. Cool. But we thought that we were missing something. That something was events from the UI. So for the view model, its responsibility is to change the state based on anything that happens outside of it that has an effect on the state. So for this, again, we looked at the Google documentations, and we saw the perfect, kind of perfect description on what our problem was. So we had to handle user events. Google calls it user events, but we realized that actually other events, other kind of events could come from the UI. So user events are actions that the user takes on your UI that, that might change the UI state. But what we thought is that, like, isn't an event when an animation ends and something has to happen? So for that, we ditched the name of user events, and we went with a view event, which became another generic parameter of our view model. So yeah, this is why, because it's an event coming from the view that has to change the state, so it became view event. How we implemented it? Yeah, the view events are just another channel, just another stream of events that has to be handled somehow. But unlike the states, this has to be handled by the implementation of the view model. So we created this abstract function so that every view model subclass has to have some kind of grasp on the incoming events, and it has to convert the incoming events into outgoing state. And of course, the view, or the outside world from the view model's perspective, has to be able to somehow pass in events into the view model. So we created this trigger view event public function that the outside world can use to pass in events to the view model. OK. So as you can see, we also had this concept of an input interface in pair with the output interface, where inputs to the view model could be handled. These could be literally anything in our implementations. So these were kind of view events. But on the other hand, we also had view events coming from data binding. So this wasn't really optimal. For the first part, we created another set of CL classes that could be passed in to the trigger view event of the view models from the view side. And these could be anything. So for example, if you open a screen and that screen received some data in an intent, for example, like the article ID to load in a detail screen, we could represent it as part of a sealed hierarchy of events. For the other part, when the events came from XML and data binding, we could just create another event. And yeah, this looks much better than we had before. OK, of course, this wouldn't be enough just to rewrite every view model to this if it wasn't testable well enough. So for testing, it turns out that this approach was pretty easily testable. For the view model state and the state changes, we could just observe the state with the Rx testing features, create a test observer, then set up our mocks, whatever we need, then call trigger view event because it's a public API of the view model, so we could send in any event just like the UI would. And then we could just assert the value of the new states on the state stream. Pretty straightforward. OK, here comes some clearing up. So we already had many things at this point that we would have to migrate and update and tell to anyone in the teams. So we decided that this will be enough. At this point in the application, we had navigation component with fragments and activities. And we decided that, OK, let's not touch that, because we would quickly spiral down migration hell at some point. So yeah, we didn't touch that. What we did instead, that we left the activities and fragments alone, but we created new base classes for activities and fragments that could interface well with our new view models, and but could still host compose. So for this, in this example, we created base compose activity. Of course, it has a pair base compose fragment. What this has by default is the need of having a view model. And it also can these classes could also handle view events and state. So you had to define the types of these things beforehand when you implement these. OK, also, of course, somehow we should be able to pass a composable inside this activity or define it somewhere. And yeah, this became an abstract function reference, an abstract function type property. We can do that, so it's pretty nice. So every implementation should provide a composable function that will handle the incoming state and transform it into a composed UI hierarchy. On onCreate, we could call setContent this way, so that the setup is done by the base classes and it's not in the hands of each individual developer when implementing a screen. And inside that, we would automatically observe the state that's coming from the view model. Of course, in our case, this is still Rx, so we use subscribe as state. If this was a flow, and it could be the newest observed state with lifecycle and such. And then we can just call the content composable, pass the state, and this is done. So now the developers wouldn't need to do this manually on every screen. And for an exact example, let's see how article details activity was implemented this way. We set the content. That composable composes the whole screen, the article details screen composable. State is received. State is set. And there's a hoisted on-button click callback. And then there we can just call the view model of the activity, call trigger view event when a click event happens, for example, and the rest is handled by compose. Okay. Of course, we can do the same thing in onCreate because we have access to the whole to the view model at any part of the activity. So, for example, in onCreate, we could unwrap the article ID that we receive in an intent, and then just set an event to the view model to start loading the article. Easy enough. Now I pass the virtual microphone to our resident Gradle master.
Thank you. Yeah, I like doing stuff with Gradle. In order to enable compose in the module that we had, we had to set some dependency and enable compose just in some specific modules. We didn't want to enable for all the modules that we have because it didn't make sense at the time. And on the top of that, we just wanted to add, enable compose and add all the dependency that we need just with one liner because, yeah, we are all lazy developer and we don't want to copy and paste stuff all around Gradle. So for doing that, we decided to go with convention plugins. So basically, in every build.gradle file of the different module that we have, we can just write a single line that sets the ID of that specific convention plugin. And that convention plugin does a bit of magic. Not magic, but it's some boilerplate code that it's written only once. So basically just enable compose, set the compiler version, set some dependency that we need, and a bunch of different things. So with just one liner, we can avoid copy and pasting all this stuff around. And as you may have noticed, for setting dependency, we are using Gradle version catalog because it's simply a very great tool for doing these things, especially for bundles, because in this way we could define a compose bundle with all the gazillion libraries that is needed for compose, and just write it with a single line without having to deal with all different stuff. And another thing that is not related to Gradle version catalog but to dependency is that we are using the compose bomb. So we can delegate to other people the choosing of the specific version that works together. So we can just import one thing and everything work, at least, hopefully. And yeah, that was that was it for Gradle configuration. Now from the beautiful build system to the boring design system.
Yeah, boring.
Yes, it's boring.
Many talks about this topic, of course. Yeah, this will be a small part again. Okay, so fortunately, we already had a design system in place at Tier. It's called Octopus. And to understand the struggle we went through to finally get to the compose side, let me give you a short history lesson of what Octopus was like before compose. That's what BC stands for. Our design system was comprised of 100% of views, all ready for data binding with custom attributes, binding adapters, and whatnot. And yeah, because of some old decisions, most of our components were extensions of previously existing platform components like test view button and so on and so forth. So we couldn't hide those APIs, but we had pretty good documentation on what APIs actually work and what not. There were workarounds. But yeah, all of that was optimized for easy usage with the view system, of course. Yeah, but actually it was not fun to maintain because of the fragmentation that views need in the code and implementation side. So just for our pretty straightforward and easy to use primary button in the design system, it required a lot of XML files and the code file in Kotlin. And yeah, just one component was all around the place. So what about compose? What we could do to mitigate this problem with compose? After some digging and reading documentation, of course, we came to the conclusion that there are two paths for us that we could choose to go compose. One is we already have the views. We already have the views, and there is interoperability in compose towards views. And we could reuse our existing components, just wrap them in Android View, set them up, and wrap all this in a composable that's called the same as the Vue components, and be done with it. But for this, we would still be stuck with our old APIs that were pretty verbose. Everything was accessible from the base classes and so on and so forth. And also, this wouldn't be fun enough because it's not much compose. There's nothing to learn if you choose this path. Of course, it's cheap. But yeah, it's not fun, so we just ditched this approach. And we decided to re-implement everything over time. So yeah, the plan was that we won't rush it. We do it step by step, component by component. And in the meantime, we will experiment with implementing compose APIs, because our design system was basically an internal SDK. So we could get some experience in implementing compose APIs that other teams would be using. Okay. Also, the API of a composable is pretty much the function that you call and the list of parameters. So it would be concise on the interface part. So obviously, I was talking about this, so we chose this path. And yeah, it was fun. We identified some benefits that we had while doing this. Of course, there will be downsides, but now the benefits. This transition involved much less code than the Vue implementation had. And actually, because we thought the API out better than what the Vue implementation had, documentation became pretty unnecessary on the API part of the composables because everything was just small, concise, and we named everything well, of course, after some trial and error. This way, we could just eventually ditch the Vue implementation when we reach the maturity in the whole application to use Compose easily. And of course, because everyone was on board, like, yeah, let's do Compose eventually. And we thought that this will be easier for teams to adopt and to get more familiar with a pure Compose, a pure Compose implementation, which every part of it would be Compose. Okay, of course, here comes the downside part. With this, we created a second implementation to maintain. So when our designers provided us some new components or changes to the existing components, we had to do twice the work. But the Compose work was actually less than the Vue work, so that says something. So at this point, we were already like a year into this process, and we had an idea. How about just going Compose first with the whole thing? Compose first meaning Compose should be the first-class citizen of our design system. And it should be compatible with our existing views that we are using. We should use Compose to render our views, And eventually, this way, we could just ditch the views altogether. And of course, if some change comes to our components from the design side, we would just be able to change the composable, which is easier to change than views. And then all the Vue usage inside the application would adapt to that change easily. For this, of course, we utilized Compose interrupt. And without going too deeply into the topic, you'll see why. There were some key points that we struggled with and we had to overcome. So first, how would you implement Vue wrappers around the Compose implementations in a way that you don't have to rewrite the whole app to support this approach? That was hard. And also, XML preview. All of our XML previews should be still working after this rework. So basically, the interface of the UI components should be the same. And of course, if you're rendering views with Compose, then Espresso will freak out because there are no views that you were looking for in the UI test, so we had to deal with that as well. And the reason why I'm not going deeper into this topic is that there is a talk about this already, which you can check out. If you're dealing with design systems and started implementing Compose or adopting Compose into your project through your design system, then this talk is for you. And I'm happy to say, after 1.5 years of work and experimenting and failing a lot, Octopus is Compose first. Now, any change or any update that we receive from the design team is first implemented in Compose, and all of the views that the app uses still are updated instantly, just by updating the Compose part. OK, so we've done a lot of things up until this point. We've done plans for migrating the view models, plans for migrating screens. Of course, these migrations didn't really happen on the large scale because that's not what the business does for us. It's not what the business wants for us to do. But yeah, we wanted to start creating new features with these new approaches, the new view models, Compose, and whatnot. And our developers were obviously on board. So, I mean, on board the idea. but we were lacking the general knowledge in our Android team, and the experience, of course, because Compose was still new. Everyone had to start learning it from the ground up. So up until now, we had experiments with our architecture, the design system. We started implementing some basic screens or re-implementing some basic screens to get the hang of how Compose behaves as, in our architecture and how our architecture is performance-wise. Yeah, all our devs were looking at us that, ooh, I like to do that. We have to develop a feature, but let's do that instead. So we started serving this need with regular 1-hour knowledge sharing sessions. These would be like existing talks, reperformed, or just watching talks, or going into some books, looking at some concepts, the documentation together, and so on and so forth. For this, we actually had a pretty good place to start because there was this existing talk by this good fellow over here. So
I'll give you the money afterwards for.
Yeah, we'll deal with that. So yeah, as I said, existing talks gave the foundation of these sessions. And then, when we were done with the basics of Compose and everyone was on pretty much the same level of understanding, we started introducing the design system, the new parts of the design system to people, doing examples, seeing how it's built up, how we could implement Compose APIs. So yeah, we had quite a few sessions of this. And then we came to a conclusion that it's time for some more hands-on experience, less theory, more practice. So we came up with these short code-along sessions that our developers could follow in meetings in like 30 minutes to 1 hour. And yeah, it became quite popular. So all the team showed up. All the team were coding along. So it turned out pretty well. So because of this, we came up with a logo. Because yeah, it's a community thing. It was a community thing. It needed something to refer to by. And yeah, it was received quite well as well. So we were happy. Yeah, some more details about this. What we've done to make this whole thing more accessible is that we created all exercises inside the main repo so that people wouldn't need to search for these materials. And yeah, this just lived in a separate branch for quite a while. And all of these sessions were recorded for further reference so that everyone could go back, redo these exercises, and so on and so forth. And yeah, the exercises themselves consisted of a starter project, an ending project, and some notes and code snippets that were useful to complete the exercise. With that, I'll give the virtual microphone back to Marco.
Thank you. So yeah, it was quite of a long journey, and we had to do many things. So let's try to sum it up and find if there's a common solution that we can adapt to every scenario. Of course, as the first law of software development, it depends, because yeah, it's going to Compose. It really depends on the status of your project, on how the architecture is done. So you need to have a lot of things in place. So most likely, you won't just start writing composable right away and have everything work. Probably it works in smaller projects, but in bigger projects where there are already convention, there are already old codes and passcode, you need to probably adapt and do some prior work in order to go with Compose. So what in general we can suggest is to take your time to just check that your architecture is working good with Compose, because going to Compose is a completely shift of mindset, is going from imperative style to declarative style. So also the architecture must be ready for that mental switch. And so, yeah, it will require a bit of time to check that everything is in place. And besides of architecture, another good point to start to actually doing Compose could be starting from a design system, because you already have a predefined space with some specific and some things that you already have, and you can rebuild it with Compose. And while working on the design system, you can familiarize with Compose API, and you can get more and more into the mood. And after that, you can move to, for example, internal settings that every app has, or something like that, and then to more user-facing feature, and then to more and more complex feature. And with that step-by-step procedure, we have seen that it was a good thing, because it wasn't an all-in at the beginning, but it was more step-by-step, and that could help. Another important thing is that this is not a race. You don't have to have a 100% Compose app in 1 year just because it's cool and it's fancy. So if you're fine using views, then just stick with views. It's totally fine. You should do what are you comfortable with and what your team is comfortable with. So don't rush it. It's totally fine to just have one screen and then go with the flow. It's totally fine. And another thing is that those kind of process requires time, so don't rush it. Take your time. We are, after a year and a half, we are pretty happy with the thing. So we just graduated the experiment to not more experiment. So now every feature team are for new stuff, they are using Compose and not the view system. We are also migrating some stuff, but again, it's not a race, so stuff is working. So we are migrating stuff step by step if we feel comfortable on doing that. Otherwise, it stays like that. But in general, we have seen that our speed increased, and also the happiness of developer increased, because it's less boilerplate. It's fun. It's good. And yeah, with that, it was all for today. Those are some links that we used for building the slides. We're going to share the slides afterwards, so don't worry. And that was it. Thank you very much.